Yesterday we saw the importance of MAC address and IP address in routing. Now, to do routing, the routers need routes in the routing table. For example, if I have a router connected to a network, so you have a switch and I got many computers. And let's say the IP address of this computer is 10.0.0.1. Likewise, .2 here, .3 here, .4 here. And I got another switch. A few more computers here, maybe 20.0.0.1 here. .2 gateways .3. In this case, you see you have an IP address here 10.0.0.4 and 10.0.0.3. Sorry, 20.0.0.3. Yep. So if you notice, the network on the port that connects to the switch is matching with the network on the computer. Same here. Now, as soon as you give this IP address on this router, the routing table is built. 10, maybe if the interface is 0, it will say 10 is connected to Ethernet 0. If this is gig Ethernet, then it will say 20 is connected to gig 0. This is dynamic. You don't need to do anything for these routes. For the connected routes, the routing table is going to show you the routes in the routing table as soon as you put the IP address. And we all know that the interfaces will be down by default on routers for security. You have to say no shutdown to get the route in the routing table. That's all. You just put the IP address and the subnet mask. This will appear in the routing table. See, it's not showing IP address there, it shows the network of that IP address. Because router needs only your network to route the packet, not the. There is no need for IP address in the routing table. Routing table is to tell where the 20 network is. The 20 network is on G0 this side. 10 network is on E0 this side. So here we got the routing table with no routing protocols help because they are directly connected network. There is no need for any routing protocol. If in case this is not here, it's here. And this is different router now. We won't have this. In this router 2, the routing table will have route to reach 20. Directly connected 20 G0. But A cannot ping B. Even if you have a wire like this, A cannot ping B. Why? For these two routers to interact, they need an IP address, they need a network. Between router 1 and 2, you need another network for them to talk. Let's say 30. 30.0.0.1 you configure on G0. And here G1 you configure 30.0.0.2. It should be of same subnet, only then they can talk. Here 30, here also it should be 30. Now as soon as you put this, additionally another line appears in the routing table. 30.0.0.0 connected via G1. Connected 30.0.0.0 connected via G0. So this appears. For this, there is no need for any routing protocol or any static route. But if I want to ping from A to B, I need a static route or a routing protocol, because this router don't know about 20 network. And this router don't know about 10 network. A is in 10 network. If the ping from B needs to come to A, the router 2 should know where A is, where the 10 network is. A is in 10 network. There is no information about 10 network. There is no information about 20 network. As a result, no ping between A and B. No reachability. So a route can be given into the routing table using a routing protocol for which we no need to write route. We need to simply enable routing protocol. Dynamically routes will be discovered and the routes will be appearing on the routing table. But the problem with dynamic routing protocol is protocols decides the route, not we, not you. So in a big topology, if someone asks how this packet will go, what is the path taken, we will not have a clear picture. Why? Because we did not write the route. The protocol has decided the route. So to know the route taken, you need to trace route, and then only you can give an answer for the question how the packet is going now. What path it is taking, you have to trace route, and then you need to see the route to confirm. But when you write a static route, you have a clear picture how you wrote the path. And at any point of time, you will be able to say via which path the packets are taking, the packets are going. So static route is our today's topic. Static route advantages, you have a clarity in the path selection. You have a very clear information how the path is taken. You know, if I ping that network, this is the route. These are the routers via which the packet is going to go. You got control over your path selection, network's path selection, which is not seen in dynamic routing protocol. Because you write statically the route, you got the control over the path. Static route. Static route is writing a route, saying here, for example, in our router one's routing table, we go and say, if you want to reach 20 network, send the packet via G0. We are saying send it like this. So router, before sending, it will put this interface MAC address as a source, and router 1 knows my gateway is 30002. So it puts the MAC address of router 2 and send the packet this way. The packet comes here and you see there is 20, the packets get delivered to B. Now when B responds back, the response packet need to go to A, which is in 10 network, but there is no information about 10. Again, we write a static route. 10. If you want to reach the 10 network, you need to go out via G1. This is one way. Or you can also say you need to send the packet to 30001. If you are saying interface, you say your own interface. If you are saying IP address, you should say the IP address of the next router, not your own. Don't put your own address there, 30002. No. Repeating again. In the static route, if you are going to say interface, it should be your own interface name. Not G1. G1 is in R2, not G1. Don't put G1. Your own G0. On R2, I have given another example. What? We are not going to give the interface, instead we want to give the IP address. IP address should be the gateway. How can your own IP address become a gateway for you? G1's IP address is not a gateway of R2. 30001, which is on router 1, is the gateway. So that's what you have to give. Static route is writing routes manually in order to forward the packet to the destination. When we write, you can write the interface via which the packet should go out, or you can also say the IP address to which the packet needs to be forwarded, the gateway to which the packet needs to be forwarded. Please ask me a question. Mm-hmm. Mm. You need to write redundant static routes, multiple static routes. How can we mention how can we know that this static route how we are getting? Okay. You are asking about the configuration part, right? Yeah, that we'll see later. Let's learn the logic first. Okay, yeah, even the logic also, like we have to say this R1 and R2 already dynamic, right? It is coming automatically in the table. So what is coming automatically? 20 is not. We have not enabled any dynamic routing protocol. See when you Okay. See, listen. We assigned this IP address to this port. As a result, this comes dynamically. We assigned this IP address, just IP address. So router knows that, okay, because the owner has put 10.0.0.4, then 10 network must be on Ethernet 0. See, this is direct on the port we configure the IP address, not the static route. We assigned an IP address on the port and the network appears. But 20 is not in this router. Why do we assign an IP address starting with 20? We won't assign. So this will never come. This will never come. This we have to write. Because this network don't belong to R1. It belongs to R2. See, in R2, 20 has come dynamically because you have configured an IP address called 30.0.0.3. Sorry, 20.0.0.3 and 30.0.0.2. Only these two networks will be coming into dynamic. See, you should not get confused with the two dynamic. I was telling about two dynamics. One is dynamic routing protocol. That is not the one which brought this to network here. These two networks appeared. That is what I mean, dynamic. It appeared itself, me without writing any static route, as soon as I gave an IP address. As soon as you give IP address, this will appear because they are on that same router. 30 network and 20 network are on the same router. Whereas 10 network is not in this router, not in this router too. 10 is somewhere in some other router. So we have to write a route to reach the 10 which is in different router. Question please. Is it clear? Question please. Okay. So dynamic routing protocol did not bring this two networks 10 and 30 and 20 and 30 of these two routers. This appeared because you put IP address on the interface. But R1 needs a route to reach 20 network which is not directly connected, for which we have to write a static route. Or we need to enable a dynamic routing protocol to discover and write a route, which we will not be discussing today. That's for another day. Dynamic routing protocol is not for today. So we are focusing on static route, meaning writing routes manually, not dynamically. Routes to reach far away networks. For router 1, 20 is far away network. It's far away. It's not directly connected. We need to write statically the route. And the other question, what Abhirami was asking is, let me draw the diagram. That's a nice question. What if I have multiple paths? Now, if someone from A wants to go to B network, let's say B is 20, A is 10. Here 10.0.0.2. 20.0.0.1, 20.0.0.2, 30.0.0.1, 30.0.0.2, Yeah, here it is 2000. Understand this topology. I'm sorry, come again? Oh, okay. Let's make 21. Okay. Now, you see, this router by default will have three networks. By default, it will have three networks that we will have in this routing table. No. I'm asking Sasikala because her question I answered. I want to check whether she understood. Hmm. Yeah. What are the three networks that we will have in R1 routing table? Yeah, it will have 10 G0 connected, 20 on G1, and then connected 30 G2. Why I will not have 50 and 40 and 21? Directly connected. So for those destinations, the router don't know where to forward the packet. If someone send the packet now, if someone ping from here, from this computer to 21001, if someone pings to this address, there is no information about 21 here. 21, I don't know. Where is 21 network? I don't know. The router will drop the packet. Why? Because the router don't know the route. So we have to write route. Now, Abhirami's question was, I have two routes to reach 21. Which route should I write? Can I write both? That was the question. Of course, you can write both if you want. If you want to write only one, that also you can. See, you can say static route to reach 21 network. You go out via G1. Then it is only going to use this route. And this route will never be used. But if you want to do load sharing, if you want to use both the paths, that's what she said, redundant path. If you want to use redundant path, then you can again say 21 network. You can also send via G2. When you do this, 50% of the traffic will go this way, which is the upper path. The other 50% will go via the below path. Sometime it will be a flow based. It all depends upon the layer 2 algorithm. When you come to CCIE level, I'll teach you that. Not always 50%, 50%. Just for you, CCNA level to understand, I'm saying 50% will go this way, 50% will go this way. That's not always true. Sometimes all the packets will go via G1. After some time, when you ping, all the packets will go via G2. It depends on the layer 2 algorithm, which is running on the router, which can be changed as per your expectation. Now, we can have. Mm, correct. Correct. In layer 3, this is layer 3. Routing table is layer 3. In layer 3, if you want to use both the paths, you have to give both the path information. But again, what I am trying to tell you is don't expect that 50% of traffic on the upper path and 50% in the below path all the time. No. That is how most of the people teach and most of the people expect in the output, but it will never be seen in the output unless you do some additional changes to the default layer 2 algorithm. Early days, yes, it was The old algorithm, which was putting the 50% on the upper path and 50% on the below path, now it is not like that. Now it is flow based. Even though routing table has got both paths, redundant paths, it will be used for redundancy. If one goes down, the other is going to be there. Not only that, it will be flow based. First flow will go where the first path, second flow will go where the second path. You need to come to CCIE for that, or you can do some self studies. No, it is there by default on the layer 2. On every routing device, it is there. Okay, so why I'm saying this now, when you do this lab, you will expect like when you trace the route, you will expect like packet to go via both the paths. But you will be surprised to see it goes only via one path. Sometime it goes via both paths. Sometime it goes only via the below path. It is all because of the layer 2 algorithm's decision. So one thing I want to very clearly say, I'm teaching static route, so I have to say this very clearly. Because you wrote static route for two paths to reach a destination, do not expect, because the route is there in the routing table. Why it is not going? Don't ask that why question, because layer 3 only suggests the path. Layer 2 is the one which is going to place the data on the path. So layer 2 also has got the freedom of choosing the path. Most of the people think and teach saying layer 3 determines everything. Layer 3, you see two paths. Both the paths will be, no. Layer 2 also has got some decision making capabilities. Layer 3 is a control plane, I agree. Yesterday also I was teaching about this in this class. Though it is saying we got two paths, it's a control plane, it says we have two paths. What does it mean? We don't have any other path. These are the two paths you can use. And layer 2 will say, okay, now I am free to use whatever I want. Thanks for the suggestion. And it will choose one of the path or both the path. That depends on the layer 2 algorithm. Now, what is this? We are going to see is static route again. Another example. You see, I want to use the same picture. If I want to go to 21 network, static 21 network, I want to go. You can say the exit interface name, or you can also say the next router's IP address. Can someone say what IP address I should give if I want to go in the upper path? If I want to give IP address, what IP address I should give? I'm on router 1, yeah. 20002 or 40002. See, 21 network is here. We are going to 21 network. We are writing static route to reach 21 network. Should I write 40002 or 20002? Very good. Very good. Very good. You know, I have seen some people doing this mistake. They will write a route for 40 also here. Static 40 go to 20002 they will write, and for 21 they will write 40002, and they say, you see, 40 we know already 40, so I can say 40002. So what will happen in this scenario? You know, a lot of route recursion will happen. See, it will work, but this is not the right way. Your gateway is this. R1 is not having R4 as an immediate router. R4 cannot be a gateway. But if you give like this, it works. But it works in a tough way, difficult way. Let me show you. Static 40 network, we have said the correct gateway 20002. Static 21 network, actually we should say the same 20002. We should say only the immediate router. But by mistake, some people say this one because 21 is connected to router 4, they say 40,002. Now what will happen? When I ping 21, the packet goes to router 1. Router 1 will check, okay, for 21 I need to go to 40,002. Now, to go to 40,002, what should I do? Again, it will look into the routing table. And then it says, okay, I need to send to 20,002. Now, how to go to 20,002? Again, it will look into the routing table. Okay, I need to send it via G1. You see how tough it is. And then it sends the packet here. See, it is going to work. That's what I said. But you see three lookups here. To go to 21, I need to go to 40. To go to 40, I need to go to 20. To go to 20, I need to send it via G1. See how much time taken. So writing like this is not a good idea. Should not write like this. It will work, but not good. We have to write the immediate router's address as the gateway. That's the logic. And when you send the packet to router 2 will have a static route here saying 21 network. You need to send it to 40,002. Then the packet is going to go here and get delivered. Okay, so now this is what called as static route, which is not possible to use if the network is too large. Why? When the network is too big, we should know the complete topology thoroughly. Then you may write static route, but not recommended because in a large network, every now and then something will happen to the connections. And you need to keep on logging into the router and changing the paths as per the new change that occurs every now and then. Repeating, when the network is too big, like 100 routers and 200 networks, we knowing the complete network is a question. We will know, but not that accurate. The paths that we prescribe may not be the shortest because the network is too large. It is difficult for us to judge the best path, the shortest path, because the network is too large. So, knowing the network, the big network, completely is a challenge first. Even if you know and you are ready to write the static route. See, writing static route for 200 networks, not easy. But you have decided to write on every router static routes. And you started writing on every router. Fine. But what happens when something goes wrong in the path that you already prescribed? You already say go via this way, but that way is already broken. Now you have to go to every router changing new path because that line is broken. You cannot recover immediately. Let's say the wire got cut and you don't have a wire for replacement. You need to log into every router to change a new path. Every router or some router, it depends on the topology design. So what I'm coming to say is, in a large network, static route is not recommended. Though the static route has got the advantage, control over your network, the path selection, still, it is not recommended because when something goes wrong, we logging into routers and changing the path manually takes a lot of time. By the time a lot of packets get dropped and people don't accept the downtime in production. See, it's not that easy. Say, for example, you are working in an ISP, Internet Service Provider. If you will make 1 second downtime, 1 second, people who are doing VPN and you may have like, let's say, 10,000 customers connected to the ISP. All those 10,000 people will get disconnected from their VPNs if they are working from home using VPN. They need to reconnect. That will become a complaint. See, for 1 second itself, no one will accept. If we are having this type of class, we may forgive the ISP guy. See, for me also, they disconnect very often, and I get reconnected. I think yesterday also you said you are not in disconnected for 3 minutes, something like that. We forgive, but people who do $1 million business, talking to the customer, they will get angry. What I'm coming to say is, a few minutes downtime itself, no one agrees. Many minutes, like 15 minutes, 30 minutes, because in a static route, for you to log into the router, correct router where the problem is, where the disconnection has happened, and then logging into it and putting a new route, it will not it won't happen in 5 minutes or 10 minutes. It will take a long time for you to figure out where the connection has gone down and where to change the route. So what we do is we leave it to a protocol to decide the route. We call it as dynamic routing protocol, which will be our later topic. Now, static route is good if your network is small and easy for you to control. And when you have redundant paths like this, good. Static route is good. You can put both the redundant, but again, that's a problem. Even if it is redundant, because you wrote two paths, because you wrote two static paths, you wrote two static paths. Even if this is broken, the packet will be kept on, sent, and then getting dropped. All the packet went this way will be getting dropped. Only these packets will be succeeding. You see? Again, static route is always a big loss for us. If it is dynamic routing protocol, as soon as this link goes down, immediately this path will be removed from the routing table on R1. So if you're 100% sure that my links will not break, everything is in control, then you go for static route. That too in a small network. Only when you have a very good understanding of your topology, you can go for static route. If you don't know where the destination is, then better go for dynamic routing protocol. That will discover the destination. Only when you know the destination where they are connected and how to reach them, you can use static route as an option. Right. Now, there is also one more called default route. Does anyone have got any question? Any question from anyone? Thank you. Yep. Yes. Small network, yes. Okay, you can um, use static route, or in some places, not in the entire topology, in some places between some devices, if you want to have a very clear um, path selection, a very particular path selection, only on that router you can write static route. You see, when a router has got static route configured, also dynamic routing protocol configured, the router is not going to obey the dynamic routing protocol. It is going to listen to what the static route says. So what I'm coming to say is you can have mixed. You can have dynamic routing protocol everywhere, and in one particular place where you want to very clearly choose one path, very particular in one, there you can go only on that router. You can write static route. So that router has got both dynamic and static. Even the dynamic routing protocol says go this way, go this way, go this way. Router will say no, I'll go that way because that is the way the static route is written. I'll go that way, not this way. Sorry. So it won't listen to the dynamic routing protocol only in that router where you want the path to be that way, not this way. All right. So you can mix both and use. Let's say we got router 1, router 2, router 3. And here we got multiple networks. 10, 20, 30, 40, 50, 60, 70, 80. Yep, we got many networks. Now, this router knows about only two networks. Suganya, what are those two networks this router knows?
10, 20.
That's all, 10 and 20. The rest of the networks, you need to give this IP address. Let's say 20002. So you need to say 30 network, go to 20002. 40 network, go to 20002. 50. Like this, you need to write all the rest of the networks and point towards the same gateway, which is 20002. Instead of doing that, you can write something called default route. Default. You can say any network. Default means you will have a symbol like this star, S star, static default. Anything this router don't know, those packets need to be sent to 20002. Simple. That solves the problem. So if I ping from here 80001, that 80 is matching here, any, then packet will go to router 2. If I ping 70001, then also packet will go to here. Any destination for which there is no route, for those destinations, this is what the match. This is where the packet will get matched. This is the route, static default static route. So default static route avoids writing too many routes which has got the same gateway. Too many destinations which has got the same gateway. Now, can someone suggest me where all I can write this default route and where I should not write the default route? Where all we can write the default route, where all we should not write the default route. Okay, my question, direct question. Can I write the default route here? See, this router also knows only about two network, 50 and 80. Can I write a default route so that this router will forward the packet to router 2, 50002 to reach the rest of the network? Can I write? Yes. Yes, of course, yes. So we can write saying any network you don't know, you send it to 50002. So now if someone pings from here 10001, it'll get matched with this and packet will go here. But we cannot write it on router 2. Why? No, 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 no. See, router 2 do not know, according to this topology, router 2 don't know about two networks. What are they? 10 and 80. Okay, I want others also to answer. Others, please. Router 2 do not know about two networks, 10 and 80. Now, someone answer, is 80 and 10 in same direction for R2? For R2 router, is 10 and 80 in same direction? Why again same Abhi's answer? What about others? Router 2 to reach 10 and to reach 80, will it take same direction or different direction? Okay, router 2 is in which direction? Sorry, 80 is in which direction? In router 3 is, yes, correct, correct. So if you are writing static route, you will say 80 network, go to R3. Or you can give the IP address 50001. 50001. And if you are going to 10 network, you will say you need to go via R1, which is 20001. So, because they are in different direction, you cannot write a default route. Whereas here, if you see, for R1, all the unknown destinations are in same direction, same gateway. But in R2, some unknown networks are via R3, or in our case, it's only one. One network is via R3 direction, one network is via R1 direction. So you cannot write default route when you have multiple gateways for various destination. So how they will say this in technical term? Do not write default route in a non-stub router. In another word, write default route only on the stub routers. Write default route only on the stub router. What is stub router? The router that has got only one exit, only one gateway. That's the meaning. Only one gateway. Router 3 and router 1 has got only one gateway. See, in our real network, mostly the edge routers, the last router will have only one gateway. If any router has got multiple gateways to reach different destinations, like here we have 10 gateways 20001. For 80, gateway is 50001. If the gateways are more than one, you cannot use default route. You need to write precise static route like this. You need to write precise static route. So default route is only on the edge routers or the stub routers. Okay, so this is a small flexibility because in the real world, real network, you'll have many routers. Only you will have privilege of writing this default route in one or two router which is acting as a edge of the network. All the rest of the routers you have to write precise route. And if you are feeling tough, if you are feeling difficult to write that, better go for dynamic routing protocol. Okay, so what we are going to see in our next classes, we are going to see how to write the static route and default route in the command line. So I'll take you to the command line and walk you through the syntax, the commands, the configurations of static and default route with an example. And we'll also see where all we can make mistake, the troubles. Troubleshooting is not a topic. Troubleshooting is a mistake done and you are correcting it. Why in first place you put trouble and shoot it? Don't make trouble, then there won't be troubleshooting. If we do if we know what you do, there won't be trouble and there won't be a troubleshooting. So doing things rightly will avoid troubleshooting. Let's see tomorrow when we do static route and the static route and default route, where all we will make mistake that will cause trouble and troubleshooting. After that, we will get into a new topic called dynamic routing protocol. Anyone has got any question on today's topic? Please ask. Right, if no question,